Hello everyone, my name is Prashant Mohan Thakur and I welcome you all on Competition Valley. We are still doing division and remainder. This is the fifth video on division and remainder. So again, today we will be learning some good concepts and we'll be doing some questions that will help us to establish the concepts as well. Okay, so we'll start today with a very important and very famous concept, which is Euler number. Now this Euler number is different from what a Euler constant is. It's not equal to Euler constant. Okay, now Euler constant is used in mathematics and physics. It's as long as pi, so don't get confused about this. This is entirely a different thing and this is entirely a different thing. Okay, so Euler number is not equal to constant, so don't get confused about this. Okay, so we'll be doing Euler number and we'll see how Euler number has great application in finding remainders. Okay, so first of all, what is a Euler number? Okay, so let's define that. So let's see, there's a number. For example, let's take 4. So if I ask what would be the Euler for 4, so how we would find that? So let's find the factor of 4 first. 1, 2 and 4. Okay, so what would be the number which would be less than 4 and it would be co-prime to 4? Okay, see, 4, 2. Therefore, Euler 4 is 2. So what 2 again? So what do we see from 2? That first of all, it is co-prime to 4 and it is less than the number 4. So one property we can figure out that it's less than the number n, and the second it's co-prime to n, isn't it? Now if I ask you what would be the Euler for, let's say, 80, so we'll have to find the factors of 80. So we can say 2, 4, 8, 10, 5, 16, 40, 20. There should be more. Let's say 2, 4, 80, if I'm not left anything. Okay, so what do we need to find? We need to find the Euler number for 80. Okay, so when I say we need to check the Euler number of 80, it basically means all the numbers that would be co-prime to 80 and that would be less than 80, less than and co-prime to the number. Okay, so how do we find it? So simply we take the prime factorization. So it should be, so no, it would be, that's what it is. So what we can do, we can simply do 80 into 1 by 2 into 4 by 5, so 32. Okay, so there would be the Euler of 80 is 32. Okay, now how I got this, I'll come on to that as well. I've taught this in last class as well, but again I'll repeat this over here as well, that how we have done over here. So let's say there's a number, let's say 20. So the factor would be 1, 2, 4, 5, 10 and 20. So if you want to check all the numbers for this number, the Euler number of 20, so simply what we are going to do, we have to take all the prime factors. So that would be 2 and then we would have 5. So what we can do, 20 into 1 by 2 into, okay, before this there's a step, hang on, before this how it happens is 20, 1 minus 1 by 2 and 1 minus 1 by 5. So it gives 20 into 1 by 2 into 4 by 5. Now once you start doing it, practicing it, you can just calculate. You will not have to do all these steps. You can just simply see and the numbers, and then you can you can do all the operation and simplification in your mind itself. So that's why I did this. So you can see 2, so you will have 8. So Euler number of 20 would be 8. Okay, So we are still doing this Euler number. Again, I'm still doing the 21. So again, for 20, the factors we know 2 and 5 would be the only prime factors. So we did this. I'm just re-explaining this concept for any of you who would have been who have come for this class for the first time, so it would be easier for them to understand. So I'm just explaining this particular concept and how we have reached over here. Okay, so let's check what we have done in last class as well. How many numbers from 1 to 30 are divisible by 3? How many numbers between 1 to 30 are divisible by 3? So what we do, we can simply do 30 by 3 equal to 10, isn't it? So there will be 10 numbers that would be divisible by 3 in 1 to 30 series. Okay, now let's go a step forward from here. If I say how many numbers between 1 to 30 are not divisible by 3. So how do we find that? So what we do 30 by 3 and we subtract it, isn't it? What we have done over here, just look over here what we have done. Okay, so what we do, so 30 we can take common, so we have taken 1 minus 1 by 3. So what we have over here is 2 by 3 is 20. This is what we have done over here. We all know that it is 20, but how we have reached to 20? So we know that in 30 this is a number that gets divided, so we have subtracted it from the entire series and then we have taken common. Okay, now let's do one more question just to get you comfortable with this concept. How many numbers between 1 to 100 are not divisible by, let's say, we can take 5. Okay, so what we need to do, we need to do 100 minus all the numbers which gets divided by 100. So 100 minus 1 by 5, 4 by 5, 100 into 4 by 5, so we know 80, isn't it? So this is what we can generalize something from here. What we can generalize it from here is if there are any numbers, if n is a number with prime factors, let's say a, b, c, then all the numbers co-prime to n would be something like this, isn't it? It would be, see, I'm just taking a number as well so that it is easier for you to understand. Let's say we have 120, so 120 is 40 into 3, which is 8 into 5, so we have 2 cube into 3 into 5, so this is n, and these are the factors, these are the prime factors. Okay, prime factors, and a, b, c, we can consider a, b, c. So how do we find? So simply it is, what we can do is we can check n, 1 minus 1 by a, 1 minus 1 by b, 1 minus 1 by c, isn't it? See, that's what we have done. While we were trying to find all the numbers which are not divisible by 30, So what we did 30 minus 30 by 3. So 30, 1 minus 1 by 3, that's what we did. And if you see 30, it is 3 into 6 into 5. We just were okay, 3 into 6 into 5, we were just looking for 3. If we want to in that series, if we want to check for all the numbers which are not divisible by 3 and 2 both, so what we would have done, 3, 1 minus 1 by 3, 1 minus, I should have done 2 first, but that's fine, 1 minus 2, 1 minus 1 by 5. I've considered 5 as well. Okay, so till here we can check for all the numbers which are not getting divided by 2 and 3. Over here, if we can check for all the numbers which are not getting divided by 2, 3 and 5. You know, in the last slide we did in series from 1 to 30, how many numbers are not getting divided by 2 and 3 and 5. So you can keep going on and you can do this way. Now again, if you look at these part over here, you can further break it as 2 by 3, 1 by 2 and 4 by 5, isn't it? I'm just trying to tell you how we can solve it in real quick time. You know, you will not have to even go through these steps, second step as well. You can simply come here straight away, isn't it? So this is what we have done over here. So let's say now I want to see all the numbers which are co-prime to 120. So we know this is the prime factor. So instead of doing 1 minus 1 by 2 and 3, simply check all the factors that you have. Okay, and multiply all the factors. Whatever the factors, prime factors you have over here, just subtract it by 1. That would be that would work as your numerator. So over here 2, so subtract it by 1, that's the numerator. 3, 2 by 3, 5, 4 by 5. So you'll not have to go through all these steps. You can simply do all these things mentally over here, and then you can calculate it. Simple. 5, 3, 15 to 30, 4, 4, 16, 32. Simple. Okay, so let's do some questions and see if it really works or not. Okay, so find the Euler number. Euler number of 240, 180, 72, let's say 91, 45. We'll do all this one by one. Okay, again 240, we know 120 into 2, 120 is 40 into 3, and 40 is 2 cube into 5. So we have 2 cube into 5 is 40, and into 6. So what we have is 2, 4 to 3 into 5. That's what we can break it, isn't it? Okay, so now simple, very simple. Do everything in mind. 240 over here, again 1 by 2 into 2 by 3 into 4 by 5, 5, 3, 15 to 38, 8 to 16, 64. Simple. Okay, how we got this part? Again, these are the prime factors. So how we have got over here is, I'm just doing it over here. So again, what we learned in last slide, if n is the number and we need to check the co-prime, so it would be n into 1 minus 1 by a, 1 minus 1 by b, 1 minus 1 by c. So that's what I've done over here. Now 1 minus 1 by a, it would be straight away. I have directly written it over here because I told you while doing such fraction we need to minimize our effort and time. So we can see over here straight away 2 is that number prime factor, so it would go in denominator, and 2 minus 1 would be in the numerator. So that's what I have done over here. Okay, so you can also do with me so that you can gain the momentum, and then later on you can practice as much as you want. So 180, 100, it would be 18 into 10. 18 is 9 into 2, and 10 is 5 into 2. So 9 into 2 into 5 into 2. So that's what we have. So basically we have prime factors. 2, 3 and 5 are the prime factors, irrespective of how many times it's repeating, doesn't matter. So it will be 180 into 1 by 2 into 2 by 3 into 4 by 5, again 648, isn't it? Simply we can do for 72. 72 is nothing. 24 into 3, 24 is 8 into 3. So 2 cube into 3 into 3 is 72. I hope so. Yep. So 2, 3, so it's 72 into 1 by 2 into 2 by 3. Okay, 91 is 13 into 7, so 91 into 12 by 13 into 6 by 7 equal to 72. Okay, and for 45 it's 15 into 3, so 3 into 5 into 3 is 45 into 2 by 3 into 4 by 5, 8. So that's how we find Euler number. Now what we have learned, we are going to apply that in using remainders, that how we can check remainders out of these. Okay, so let's take a question, find remainder in let's say 22 to the power 92 by 19. Okay, so how to go about this? Now we need to, first of all, what in such questions, what we need to do, see, 22 by 19 is one number we can consider, and then all the power that has been given, we have to divide it with the Euler of the denominator. Always remember that divide the power by Euler of denominator. Over here 19 is our Euler. Okay, so for getting Euler number of 19, it will be 18. How? I'll tell you. For any prime number, Euler is p minus 1. Remember it. For any prime number, it would be, the Euler would be this. Okay, so what we can do now, simple, 22 by 19, and we have 92 by 18. Why 18? Because Euler of 19. Okay, Euler of 19 is 18. So this is what has been done over here. Now 22 by 19, what would be the remainder? It would be 3. And over here 92 by 18, it would be 2. 18 into 5, so we will have 2 remainder. So we would have by 19, so it will be 9 by 19. So 9 by 19, the remainder would be 9. So the remainder is 9. Okay, see over here. Just what we have done, very simple. The fraction, we have divided the power by the Euler of the denominator, and denominator here is a prime number. So for prime number, it will be always minus 1, the number itself. So 19 goes minus 1, so it becomes 18. So 92 by 18, we divide it, we get remainder 18 into 5, so we have 2 as a remainder, and over here it's 3. The remainder is 3 over here, so 3 is to the power 2 by 19, we get 9. And now why we have stopped over here? Because if you would have seen my previous videos, I have explained there that remainders are always less than the divisor. Remainders are always less than the division. This is a concept, and we have done so many good questions under this. So this is a concept that would be used continuously, especially in this remainder and division topic. Okay, so now we'll do some more questions. Let's see. We can find 87 by 10 to the power 89 and find the remainder. Again, very simple. Remember what was told? We need to divide this monstrous power by the Euler of the denominator. So Euler of 10. So 10 is 2 into 5. So 10 is 1 by 2 into 4 by 5. So 4. Now try to find the Euler number, especially of these small number initially, in your mind itself. Okay, because it will help your mind exercise, and the more you use your mind to do such calculation, the more sharpened it gets. So this helps you in examination time. In real time, it would not betray you. Okay, so this is 4 over here. So what we are going to do now, 87 by 10 and 89 by 4. Now 87 by 10 is 10 into 8, so we have 7, and we have 22 into 4, 81, 1. So we have 7 by 10, and we know the remainder in 7 by 10 is 7 itself. Now, how we are getting this? We have studied this in our previous video, so please go to that video if you have not, if you're not understanding how the remainder is 7 by 10 is 7 itself. Okay. Now we'll do some more questions over here. Okay. So let's say 72 by 14, and we need to find a remainder, and let's put 25 over here. So very simple. What we need to do is 14 is 6 by 7 is equal to 6. So 72 by 14 is nothing but 25 by 6. So we have 5 and we have 1. So this is 5. The remainder would be 5. Okay. So I hope Euler number is pretty clear for all of you. And we have seen how applications of Euler number are done. So we'll stop here in this class. I would want you to go and practice this. Just look at these questions and try doing it on your own again and again. If you want, I can give you some assessment work as well if you want to do it on your own, something let's. Now I would not be solving over here. We'll be doing the solution in our next video for those. Okay. So we can do, let's say, 25 by 7, and we can do 62, and we can find remainder. Try doing this on your own, and if you want, you can do 97 by 10, and we can do over here is 91. So you can do this as well, and then you can do is 188 by 101 to the power, let's say is 100, and or we can say 100. Let's make it power 100 over here. Okay. So try doing these 3 questions on your own. Let's see how far you can go. And in our next video, when we'll be continuing things further. So we'll be getting to know the solution of these things. Okay. So hope you would have learned something, and you would have followed all our previous videos as well. If not, please go through those videos as well. That would help you to get to your concept very easily. So once again, thank you for your time. And this is Prashant Thakur, and thank you for your time on Competition Valley. Bye for now.